Hello everyone, hope you guys are doing well. On this video, I'm gonna go over the feedback for three kinds of reports. Please bear with me and we're gonna go through them all and you will use this as a feedback for your uh, kinetics report. So, we know that the topic name is the stoichiometry lab. So in here, one of the students who has written stoichiometry is the measurement of ratios in which different compounds or elements interact. Okay, so they have given information about stoichiometry and they're going to talk about experimental theoretical value question mark, which is not good. You don't really ask questions in here. You need to make statements. The experimental value is calculated by averaging the reported outcomes. The experimental value of collection of 5 integers is calculated by adding all 5 together and dividing the result by 5. So they have given an information about stoichiometry, which is good, but the information is too short. Okay, now we're gonna look if they have given aim and hypothesis in here. So it's saying that our aim in this experiment to find the amount of gas from the reaction of aluminum and hydrochloric acid. So our aim in this experiment wasn't just finding aluminum and hydroxide, it was seeing or understanding stoichiometry and using it to understanding stoichiometry, and also we used in order to learn how to do mass conversion into moles and all that different stuff. So mass conversion to mole and etc. But it just when they narrow it down like in such a small aim, it's not good. And in my hypothesis, now again, you shouldn't state with my, you should go from third person perspective. Third person, you should say following hypothesis has been stated. You need to write in past tense of passive voice, okay, from the third person perspective. So now in my hypothesis, in this lab we'll make different sizes of aluminium and put them in tube and heat them. While putting them, we will measure the gas with the help of burning hydrogen. If it explodes, it means gas is released. If not, gas is not released. So now this is not our hypothesis. Our hypothesis over there was that we were finding as we were increasing size of aluminium from 1 centimeter to 2 centimeter and then 3 centimeter, the number of hydrogen amount released was going to increase. So the graph would be V of hydrogen 2, the volume of hydrogen 2 was going to increase as you would increase the 1 centimeter, 2 centimeter, and so on. So your graph would be looking like this. This was your hypothesis, so the hypothesis is wrong in here too. So this person is most likely gonna get either 3 or out of 10. Okay, so all of the stuff is, it could be 3, 4, so depending on condition. Compared to other students, we also take into average of the other students. So now materials. You see this material is not introduced. You need to introduce it, write figure 1, give it a title, and it's been forgotten. And you need to number all of the equipment, say this is 1, and then let's say this is 2, and then this is 3. So you need to have a picture, so you have this guy, this holder, so all of this stuff needs to be numbered. And then underneath you would write, okay, we have following stuff. So you have written plastic balls, test tube, water, sand. I don't know which one is what. What if I don't know what is pipette? What if I don't know which one is heater? And you didn't even show the heater in here. So materials needs to be presented and there shouldn't be no list. You shouldn't go like 1 is this, 2 is this. You need to write a paragraph. And in paragraph you would say that, okay, so this and this and this equipments were used And when you write equipment 1, you just would write the, for example, you should write tongue, and you will write 1 beside it, and then you would write match, and then you would write 2, and that's how you would write your paragraph. Now about procedure part, let's go in here. So for materials, I'm gonna give this person 2 out of 5. To be honest, I would give even less, but this is they didn't even capture all of the materials. Now procedure. In the procedure part, in this experiment, aluminiums have to be taken with the size of OK. After this, aluminium pieces have to be torn into some pieces. Okay, this is good, we have done it. After that, 15 ml of hydrochloric has to be in the test tube. How it has to be? Like, you need to actually pour it, you need to say that pipette is used. Okay, pipette is used. And then 15 milliliter of hydrochloric acid. What concentration? You didn't even say what concentration of hydrochloric acid gotta be there. After those, small pieces of aluminum have to be put in a test tube closed with a rubber plastic test tube, and add another which is filled with 90 milliliter of water, has to be in water. After heating aluminum all together, the decreasing of water which is in test tube has to be measured, and this process has to be repeated 3 times. So this person actually missed a lot of points, a lot of details. This is too short. You need to go really into detail. You need to say, how did you set up this equipment? Do you remember we filled out the water? We filled out the water in graduated cylinder, and then we put it upside down, and then we had to make sure hose, you see the hose inside is actually inside the graduated cylinder, and it is connected to the test tube with the side arm. It's not a regular test tube. So all of this stuff needs to be detailed, and this person didn't go into detail, and the maximum point they would get out of 10, it's going to be 4. Okay, and then data recording. So water amount in the test tube after experiment 40 ml, 22 ml, and 10 ml, and the changing amount of water was like this. So data recording, I would like to have a table, and you didn't present a table. It's just, and then analysis discussion, they went to it, and this is super short analysis discussion. There is nothing in there, to be honest. In this experiment, we can see that small size of aluminum released lesser than medium and big pieces, because a small piece has a small area and it's not closer than medium. Big ones, small aluminum pieces are not more than big one, medium one. As I can say, my hypothesis became wrong. So to be honest, in here there was nothing, so I give 0 out of 65 for this person on analysis and discussion. Maybe, okay, maybe if we be a little, if we want to give a little points, we can give 10 out of 65. And then conclusion, I've learned that the small aluminum pieces release lesser than big, medium ones, and how to work with how to see, calculate, measured gas. So this one is not gonna be either a lot. It's gonna be, we can give 2 out of 10 for this person. Even this one is debatable, so that's pretty much it. So this is a weak report. So 6 plus 10, and then 16 plus 5, so 21 points. 21 points for this person out of 100. And then we got another report, and this on this one though, you can actually see that they talked about stoichiometry. They went to it quite well, and then enough information about stoichiometry, and then they want this into our aim. Let's check out our aim. This reaction will not take place as soon as piece of aluminum is added to hydrochloric acid. It occurs as a result of piece of aluminum being converted in an aluminum oxygen layer. Now this one seems like everything is quoted from internet. There is nothing to be written by themselves. It will take some time for the hydrochloric acid to dissolve through this period, but once it does, the reaction will proceed rather vigorously. Hydrogen gas will start to bubble out of solution. The aim of this lab was finding the amount of gas released using aluminum reaction. Again, this is too narrow aim. You need to talk about stoichiometry. For this one, this is a long hypothesis, and they didn't even talk about aluminum pieces and increasing trend. As you increase the aluminum size, you will release more hydrogen gas. They didn't even state this, so I'm not going to consider this hypothesis written well, but the introduction is okay. So this point, person will get either 6.5 or 7.5, depending, as I said, on the average of the students. So now about materials, you see there is no picture. You have to actually have a picture in here. You need to present it properly and all of this stuff. Okay, there was no Bunsen burner. We had actually alcohol burner, weighing both test tube holder, goggles, aluminum foil, delivery tube. Delivery tube, I guess it's a tube with a sidearm. And then they had test tubes. So the amount of hydrogen gas is measured using graduated cylinders, safety equipment such as gloves, goggles. They forgot about the lab coat. That was a safety equipment. A test tube holder secures the test tube. In addition, delivery tube. And a posture pipette is used to add hydrochloric acid to the tube. The reaction occurred in a test tube using a weighing boat, aluminum as weight. So this stuff, they went to it, but as I said, this is going to be 2.5 out of 5. They didn't present the picture, so I don't know which one is which. You need to look at it from the perspective is that I'm not a chemist. I am not a chemist. I'm reading your report. I need to be able to repeat everything. Okay. So if I don't know how the thing it looks, I don't know what I'm gonna do. I can't. You can't tell me that go you use Google or something like that. No. We're talking literally just your report, and we have to have a picture to be able to repeat the experiment. Okay, and then procedure. They went to it. If you would check this out, if you want to stop it, you can pause the video and you can read it. Over here, I can see that it's too short. They didn't talk about how it was set up. It just says set up. How did you set up? You had to describe how was the equipment set up, and then they didn't really go that much into detail. So on this one, I'm gonna go like 5 out of 10 for this one. And then data recording, it's not bad, it's pretty good, but I would say you need to have percentage error in here, and then to get the percentage error for each one. So this graph is not good. First of all, you see this, I don't have a grid lines in here. How do I know that this graph is correct? How do I know about this? There is no way. So you have to use Excel or some kind of graphing sheet, so that I would know that your graph is right. Okay, these numbers are good, but your graph is not good. Okay, and then analysis and discussion. Now everything is written. They have put the picture in here. Like for this lab, it was okay, but for your kinetics lab that you guys are gonna write tonight, you cannot have a handwritten version like this. I have checked all of the calculation. I know they are right, so they have done a good job in here, but they took the pictures, which is not acceptable. They put the formula, okay, but still, look at here. The only thing that was given in analysis and discussion section was just calculations. They didn't talk about their calculations, what those results meant, and how the errors occur, what was the source of error. Like this stuff needs to be discussed. So none of this stuff were discussed, so I'm gonna cut quite a bit of points for this. So most likely I will give around 35 for this person, so because I need to compare it with the other one's work, as I said, with the average. So 35 for this is gonna be given, and then because I'm cutting a lot of points for not explaining the stuff. And then we have here conclusion. Let's check out the conclusion. In conclusion, you need to say, what did I learn? And how could you improve? how can you improve things? What could you do? What could you do to make things better? Make things better. Okay? You need to do this. Now, the measurement taken during the experiment allowed the stoichiometry and reaction rate to be identified. The higher temperature was applied to speed up the reaction. To sum up, the volume of hydrogen is influenced by mass of aluminum. If hydrogen mass is higher, it will have a larger volume. Now, this one, it was, yes, they have talked about the trend, but what I can say here, they didn't talk about what did they learn and what could be done better. They didn't answer this one either, so this is really losing the half of the point. So we got here what, 6.5, so I got 9, and then I have 35, 44. What did we get? 9 plus 5, 14, 14 plus 35, 49. So I wouldn't be able to give more than like in my opinion, more than 3. More than 3, or I would cut from results and discussion. So it's gonna give, it adds up to 9 plus 5, 14 plus 35, 49 plus 3, 52. Okay, that's the 52. So this is the mid-range report. Now we're gonna go into relatively higher range report. So in this one, you could see the stoichiometry. Everything is talked in detail. You can pause the video and actually look for this report. It's quite well. I'm actually impressed, but there are still areas that I need to cut points. I'm going to show it, so you can read all the stuff about stoichiometry, but everything is well in here. Okay, so on this part, the main aim of this experiment is set the relations conversions between moles, and this is quite good. And then it's expected that the experimental volume of H2 will be the same as the theoretical volume of it too. So in here they made the hypothesis saying that the error percentage would be 0. To be honest, this is not really possible as a hypothesis, but still it's unacceptable. So I'm gonna give this point 10 out of 10 for here. And for material section, as you see, they give figure 1. They even gave the title for the figure. It just shows that figure 1 shows the experimental, so they even introduced the figure. They numbered everything, which is beautifully written, and they even showed here what is what. For example, they put aluminum foil. As soon as you come back here, you check out number 10. Yes, it is aluminum foil. So everything kind of matches in here. So I'm reading this beautiful report, and I can see that everything is going well in here. So I'm gonna give 5 out of 5 for this one. And the only thing that is missing in here, they missed the, no, it's here. And I'm gonna move on. Maybe this holder, this is a separate one. You need to give clamp another separate number. And then we're gonna go into procedure. Now it's here, they went, firstly the mass of each aluminum foil was measured in a scale, data was recorded. H-chlor was poured into graduated cylinder, and then 50 milliliter of hydrochloric acid. Again, the concentration is missing. Concentration is not given. And then 3 centimeter length was added, and you need to cut aluminum into pieces. It's also forgotten. We did that. And then the volume of water in graduated cylinder was measured, recorded, okay, for speeding up the reaction. So this procedure in here, they actually went quite short. This is too short, okay? And I think it needs a lot more detail than this. You need to describe how the water level in graduated cylinder dropped down, and you need to go into detail. You need to explain how was the system was set up. They didn't talk about this one either. So we're gonna cut points. So we got 15, and then from here I'm gonna give most likely 5 or 6 out of 10. And then we're going into data recording. Now data recording is quite well. The only thing I would add here, I would add error percentage here to calculations. You see all of the stuff is quite well written. It's actually one of the good ones among writing the calculations. Every step is taken well. So this is pretty good. And the only thing I would change, you see the mass of aluminum, it's used in different fonts. So the font doesn't match. So you see this one is Times New Roman, but this is written in, I believe, in Calibri. So it needs to be matching. And then you also need to give it figure 2, the name for this guy, figure 2. And then you need to give it a title, introduce it as well. And then as you see, the results and discussion is super short, like for so much data. And then now we go into it. Now let's look at here. I got, according to the results, some huge percentage of error can be seen. This is due to the several accidents that happened during the experiment which contributed to those errors. Firstly, before the measurement 2 centimeter and 1 centimeter of aluminum, the entrance of the test tube, it was connected with the pipe, was broken. So there was an accident in the lab that caused some of the H2 go into air rather than through the pipe, and the amount of hydrogen released in the graduate was lower than the theoretical amount. Okay, so there was a problem with the equipment, so that's why they have written it. Second factor was that during the measurement of 1 centimeter of aluminum graduated cylinder was full with water, no space or air inside it. It literally released hydrogen, not being able to move through the graduated cylinder. So in here, I'm seeing that error discussion, okay? But you needed to present your error in some way. So let's say you have error for 1 centimeter aluminum, 2 centimeter aluminum, and then what do we have here? And 3 centimeter. So as you see here, we have error percentage, right? You can graph this error percentage with this and explain us what kind of trend is there for the error. You needed to talk what kind of trend is in here. Talk about your graph, okay? So this stuff, because it was not discussed, I got the cut points in here, and then overall I believe I cut from here. So I got 15, then plus 6, 21, and then 21. And for here, I'm just going to look into the conclusion too. As stated in the end, molar mass, mole relations were investigated. Also, the analysis which was made related to errors discussed above and ways to improve and correct mistakes which were done during the lab. Help to understand this concept and their applications. Okay, but what could you do better? What could you do better? Okay, you need to improve the experiment, right? We're done during the lab. Help to understand this concept. So this is part of it. It is missing. So I'm gonna give, from here I would give 7 out of 10 for here. So we're gonna give around like 55, 56 for 55 out of 65 for this person. So that adds up to 55 plus 7, 62 plus 2, 68 plus 15. It adds up around 83%. Okay. Well, this is a pretty good report, but still there were some stuff that you needed to include. You really need to discuss all of your data points. You need to discuss your graphs. You need to discuss your errors. All this stuff needs to be discussed. And references, this time you don't need to have it, so don't worry about it. Okay, so now about regarding our lab. So in here we did the experiment. You got the points, so you filled them out, and then you have a graph place. But I wanted to talk about the stuff for the questions, so kind of help you guys out here. It says use your graphs to explain the following: the effect of increasing concentration of hydrochloric acid on the reaction rate. So now the thing in here is that you're gonna include VCO2 volume, right, ml, and you're gonna write it with time. You're gonna draw your graphs. Okay, so you're gonna draw your graphs with different concentration. One is gonna be 0.25, one is gonna be 0.5 molarity hydrochloric acid. So I wanted to explain this is that concentration equals to N divided by V, which is mole, and this is volume. Okay, and then mole divided by liter is actually 1 molarity. That's why we have written 1M, big M. But in your case, we have here, we did it with, yes, milliliters. You need to know that centimeter cube, 1 centimeter cube is 1 milliliter. Okay, you're going to use this information to answer this. So once you have drawn your graph, you're going to talk about this in your results and discussion. Final volume of gas produced. Again, you need to look at your graph and you see where was the final volume, and that's how you're going to answer in your results and discussion. Again, talk in your results and discussion. And then draw tangents at T0 for each line. What did their slope show? So you have two graphs, so you need to draw tangents. Okay, you need to draw your tangents. So you're gonna do your tangents, but the thing is, guys, you need to print your report. Print your report, print your graph, and then on top of your graph you will do your tangents. Okay, without the graph you won't be able to do this part. So you need to print your report, or if you have Paint or tablet, you can use them in order to draw tangents. Okay, tangent. Now calculate the following quantities for experiment 1 and 2. The initial rate of reaction. Okay, so do you remember we measured volume of CO2? We said milliliter, and milliliter is same as centimeter cube. You had with time. So once you go with your tangents, you draw for initial rate for different graphs, you will get your initial rate. And then it says over here, initial rate of reaction in terms of centimeter cube of carbon dioxide gas performed per second. Because your time was given in here was second, as soon as you find your graph, delta y over delta x, which is over here, this is v, right? And this is t, which is delta v over delta t. And then from here, you can get your value in centimeter cube over second. And then for this one, initial rate of reaction in terms of mole of carbon dioxide performed per second. So you know that centimeter cube, let's say 24 centimeter cube per second, right? So this is 24 centimeter cube per second. And then you want to find out how many you have for the 1 mole. Is that clear? So there is one thing you need to find out. 24 centimeter cube per second is x mole per second. You know that 24,000 centimeter cube per second. Do you remember 24 liters at room temperature, RTP, was 1 mole, right? So that 24 liters is 24,000 milliliters, which is 24,000 centimeter cube. So 24 centimeter cube, which will be 1 mole. Now you do your cross and cross and you get your moles. Okay? And then initial rate of reaction in terms of change in number of moles of hydrochloric acid per second. Now this one, for this you need to write your reaction. Okay? You need to write your reaction. You need to balance this. For this report, you have to have your reaction written, guys. So now here CO2 is coming out, right? So because we measured the volume of rate of reaction with change in volume divided by time, right, of CO2. Now rate in terms of disappearance. Now in terms of initial rate in terms of hydrochloric acid will be like this. Because you see we have a unit of 2, you will multiply the rate by the coefficient of 2, which would be rate multiplied by 2, which would be delta C, the concentration of hydrochloric acid, divided by delta T. And whatever number you get from here, here, you're gonna multiply it by 2 in here to get the answer. And then now record your answer in the table. So this one, mole per decimeter cube. Mole per decimeter cube is actually mole divided by liter, which is mole divided by 1000 centimeter cube. So you can do all of your conversions. Rate production, so you need to fill this one out yourself using the calculations in here I showed. And then calculate the instantaneous rate. You know that once you have your graph, whatever the 30 seconds is, you're going to pinpoint this and you're going to draw your tangent and you will measure. So this would be x2, y2, and this would be your x1, y1, this point. And you will do delta y over delta x and you get your answer. And then calculate the average rate. This is super easy. Again, we have done it. So whatever you have the difference, so as soon as it stops here, so this is your delta t, the time in here, and this is your delta v. So wherever it kind of stopped, you see like this part, just before that you're gonna put your point for v, and over delta t you will get that, and that's gonna be your average rate. And that's about it, guys, for in terms of lab report. Now in the next, like the continuation of this, you're gonna see our use of Excel in order to input and get your graph.